In this video, we're going to be looking at writing transformations of graphs of functions. So number one says, let the graph of g be a reflection in the x-axis. So that's my first transformation, followed by a translation 4 units right of the graph of f of x is equal to 2 to the x. Write a rule for g. So I'm going to do this in two parts. I'm going to write a rule for that first transformation and then finish it out with that second one. So that first one is a reflection in the x-axis. So that means that h of x is going to equal to negative f of x. And if you need to recall what that reflection in the x-axis is in function notation, you can look back at this chart. And so I see reflection in the x-axis is negative f of x. So when I do that, I get that h of x is just equal to negative 2 to the x. Now I can write my rule for g. So g of x, on top of that, is a translation 4 units right. And so when I'm going 4 units right, that means with my h, I am subtracting 4 from x. And so when I do that, I'm replacing my x with x minus 4. So that means that g of x is equal to negative 2 to the x minus 4. Okay, let's look at one more. So here it says that let the graph of g be a translation 2 units up, followed by a vertical stretch by a factor of 2 of the graph of f of x is equal to log base 1/3 x. Write a rule for g. So first I'm going to write a rule for h just to show that first transformation. And that first transformation is that's a translation 2 units up. So that means I'm going to take f of x and I'm adding 2 at the end. So that means that h of x is just going to be log base 1/3 of x plus 2. Okay, and then for my function g of x, I am following that with a vertical stretch by a factor of 2. So for a vertical stretch, I am multiplying the function by 2. So I'm going to say this is equal to 2 times h of x. So that means it's 2 times log base 1/3 of x plus 2. And so when I distribute that 2, I get that g of x is equal to 2 log base 1/3 of x plus 4.